We're meeting Dag Svanes in Aarhus in Denmark, and Dag is a professor at the Norwegian University of Science and Technology in Trondheim. And since the late 1980s, Dag has been doing research in HCI, and one of his main areas of interest is the philosophy of interaction. Yeah, so let's go back to the cognitive science. We have now an overview of the different perspectives, and but since the birth of HCI, what has been the dominant paradigm for describing the interactivity or the human side of interaction?
The dominant side has been this cognitive perspective, but to a large extent it's not even made explicit. Often if you have a study of different input devices, so the classical study in HCI, on what is how do mouse interaction compare to using a stylus, for example, or one-handed interaction versus two-handed interaction. Most of these studies, they don't even make explicit the underlying assumptions. They just start out with describing an experiment where they do this and they do that, and you have this condition and you have that condition. And you just describe your experiments and your findings and your interpretations. So it's not necessarily any sort of deep philosophical background in a lot of these publications or in a lot of this research. It's more what we take for granted when we study human-computer interaction. And some of the things you take for granted is that you have a symbolic representation and that you have some kind of conscious, that the user is conscious of what he or she is doing.
Yeah. Which
is some of the implicit assumptions here.
And I can hear that you think that's kind of a problem. Why is that?
It's a problem in the sense it's to what extent you think that it's actually literally, that people literally have a model. So it's useful as a tool. For example, if I want to design a thermostat or a user interface for a thermostat, then you have this concept from cognitive science called mental models, saying that people have mental models of the behavior of artifacts. So when I drive a car, I have a mental model. I have my understanding of how the car works. I have this understanding that when I turn the steering wheel, the tires move, and when I sort of press different handles, things happen. So I have this understanding of the internal working of the car. This is my mental model of the car.
Yeah.
And when I use a mobile phone, I have this mental model that when I just press the numbers, then I'm connected to someone. This is my understanding of my mental model of this artifact.
Yeah.
Which is of course a simplified version. I mean, the real thing is 1,000 times more complex with all the digital signals, etc., etc., etc. But I have this simple version, simple understanding. And in cognitive science, we have this idea that you can describe this mental model as a set of rules or a set of relations between objects. So you describe it as if it was some kind of a diagram, my internal map of this artifact, of the behavior of this artifact. And for example, if I want to build a thermostat, that makes sense, because if you go into how people perceive thermostats, you find that kids, when they see a thermostat where you can sort of change the temperature from sort of 10 degrees, 20 degrees, 30 degrees, a lot of kids think that it's just to turn it up. If it's cold, you turn it up, right? Like if it was an oven.
Yeah.
So the mental model of the thermostat is that the higher temperature, the faster the room gets heated, which is a false mental model. Or we would say it's not a correct mental model, but it's still a mental model that makes sense.
Yeah.
And that is an alternative mental model from the real thing, which is of course that you turn up to the temperature you want, and then you just wait for the oven to heat it up, and then automatically it will sort of flip on and off to keep the temperature steady, which is kind of complex to explain to a 5-year-old.
Yeah.
So the thing is, if you want to make a user interface that also works for kids on a thermostat, you have to do some thinking. And then it's very useful to have this concept of a mental model, because it reminds you that there are some internally consistent ways of misunderstanding this. Ways of understanding it that make sense but still are wrong.
Yeah.
So when you build the user interface, you should sort of make sure that this alternative perception of what the thermostat is not sort of that you in some way that you communicate the right model.
Yeah.
To put it like that. So that's a good example of where it makes sense to think in terms of the cognitive science perspective. But the idea is that you shouldn't. It works even if it isn't real. I mean, people don't have models. If you do a MR scan or something of the brain, you won't find that model.
No.
It's nowhere in there.
No.
And even if you ask kids to draw the model, they won't be able to draw the model.
No.
So it's not in there in any sense, but still it makes sense to model people. So if you take it as a model of people's understanding, so it's not people's understanding of the kids' understanding of the thermostat, but it's our model of the kids' understanding of the thermostat.
Yeah.
So if you take that extra step, then it's okay. But it's like you shouldn't take it literally.
Yeah.
That's the whole thing. It's metaphorically in a way.
Has it been taken literally?
I don't know. I mean, most textbooks don't really make that distinction. They say that the user has a mental model.
And that's it.
And that is.
Yeah.
Or you say the mental model of the user.
Yeah.
And of course it gets a little bit more complex when if every sentence you have to say our model of the understanding of the user.
Yeah.
And not even of the user, but of an idealized user, not necessarily connected to any specific user and a specific use situation, and of course a simplification and etc. So instead of this long academic explanation, we say that the user has a mental model.
Yeah.
But if you take that literally, then from my perspective, it's too simple. It can gives you the sort of false. It's just psychologically wrong.
Yeah.
It's not. It's not correct. But still, it works. As a design tool, it works.
Yeah.
But if you want to do science, then it's not precise.
Okay, so in your opinion, is there a better way to understand the nature of interactivity?
Yeah, and I'm not the only one who's been inspired by Heidegger and phenomenology. And going back, as I said, to Terry Winograd and Fernando Flores and their work back in the mid-80s. And for me, it was their book then in '86, and reading about Heidegger, and this was because I've been struggling with some of these things, feeling that these cognitive science theories didn't really sort of get to the core of what human-computer interaction was all about. And there was something missing here, I felt. And reading Winograd and Flores was really sort of an eye-opener for me.
Yeah.
And even if they have also a very simple simplified version of Heidegger, and they just do some aspects of it, but this idea that we are as users, we are not sort of primarily thinking and planning. We are in the environment and we act, That's the primary thing.
Yeah.
And that's the whole Heidegger idea, that we are, which is the break that Heidegger did back in the late 1920s with the philosophical tradition going back to Plato. So the break that we're not sort of primarily cognitive, thinking, reflecting people, individuals, beings. We are in the world.
Yeah.
That's the primary thing. And then we should start with the way we are in the world. And then he starts his analysis of how we are in the world as a starting point for understanding what it means to be human.
Yeah.
Which is the whole philosophical thing, which is not really my topic. I mean, I'm not a philosopher, but I'm inspired by these ideas. And a lot of people have been inspired by them because it makes sense. I mean, a lot of it is just common sense.
Yeah.
Simply common sense.
So we've reached the end of our interview. Thank you so much, Dag, for coming here and for sharing some interesting perspectives with us. And if you want to know more, you could have a look at the other videos with Dag, and you can read his chapter at interactiondesign.org. Here you can also find more chapters all written by thought leaders and inventors, and you can find videos like this one as well. Thanks for watching.